Welcome to another session of sequences and series. This is part 7. In this video, we are going to discuss about the sum of the infinite converging series. We find S infinity of the converging series. Sum to infinity of convergent series. The formula for the sum to infinity of a convergent series is S infinity equal to A over 1 minus R, where R lies between minus 1 and 1. So this formula is available on your formula sheet. Make use of the information sheet. Calculate the sum to infinity of the geometric series 1 over 2 plus 1 over 4 plus 1 over 8 plus etc. So we are going to calculate the common ratio. A is half. Common ratio 1 over 4 divided by half gives you 1 over 2. Since the common ratio is between minus 1 and 1, the series converges. Then we use the formula for S infinity equal to A over 1 minus R. Substituting into the formula, A is half, R is half, and we get 1. So the S infinity or the sum to infinity of the series is equal to 1. A convergent series has second term 8 and the sum to infinity is 36. Determine the possible constant ratio or ratios. Second term, that is T2 equal to 8. Therefore, AR equal to 8. Therefore, A equal to 8 over R. Again, the sum to infinity, S infinity, is 36. That is A over 1 minus R equal to 36. Therefore, A equal to 36 times 1 minus R. So we have two equations as A the subject. So we can equate those two equations. Therefore, 8 over R equal to 36 times 1 minus R. Multiplying by R, we get 8 equal to 36 R times 1 minus R. Removing the bracket, 8 equal to 36 R minus 36 R square. Changing in the standard form, we divide all the terms by 4. We get 9R square minus 9R plus 2. We get 0. So that is the standard simplest form. Factorizing, we get 3R minus 2 times 3R plus 1. Therefore, R equal to 2 over 3 or R equal to minus 1 over 3. Two values of common ratio. The seventh term of a geometric series is 1 over 128 and the 11th term is 1 over 2048. Question E. If R is less than 0, determine the first term of the sequence. Okay, a question from geometric series here. T7 is 1 over 128. That is AR to the power 6 equal to 1 over 128. Question number 1. T11 is 1 over 2048. That is AR to the power 10 equal to 1 over 2048. Equation number 2. Divide equation number 2 by equation number 1. We get R to the power 4 equal to 1 over 16. Therefore, R is equal to, get fourth root of 1 over 16. Okay. which is plus or minus half. But in the question, it is said that r is less than 0. Therefore, we consider only r equal to positive half. Now we are going to solve for the first term. Question number 1. 8 times half to the power 6 is 1 over 128 is 8 times 1 over 64 equal to 1 over 128. Therefore, a equal to 1 over 128 divided by 1 over 64 gives us positive half. A is half, common ratio is half. Okay, so the question is determine the first step. A is equal to half. Question B, will this sequence converge? Explain. Okay, depends on our common ratio. R is positive half. And it is lying between minus 1 and 1. Since minus 1 less than half less than 1, the common ratio, this series converges. The first two terms of a geometric series is root of 3 and root of 3 minus 1. Determine the value of S infinity. So we are given the first term, we have to calculate the common ratio. That is second term divided by first term. That is root of 3 minus 1 over root of 3. Writing the formula from the formula sheet, substituting into the formula, and then we simplify as much as possible. Carefully simplify. We get the final answer equal to 3. Given the geometric series 9x squared plus 6x cubed plus 4x to the power 4 etc. For which value or values of x will the series converge? So we have to find the common ratio. Common ratio is 2 over 3x. Now we know that the series converge. So for converging series, what is the property? Minus 1 less than or less than 1, or the common ratio is between minus 1 and 1. So we use that idea here. Minus 1 less than 2 over 3x less than 1. Our intention is to calculate the values of x. How do we get the values of x? Here it is 2 over 3x. We want 1x. So multiply by 3 over 2. But in this inequality, we have to multiply all the terms. Minus 1 times, we multiply all the terms by 3 over 2. Minus 1 times 3 over 2. Minus 3 over 2 less than x less than 1 times 3 over 2. That is 3 over 2. These are the values. What's the meaning of the answer? The values of x lies between minus 3 over 2 and positive 3 over 2. Consider the infinite geometric series P plus P times P plus 1 plus P times P plus 1 whole square plus etc. Question A. For what values of P will the series converge? So we know that the series is convergent. So calculate the common ratio. P times P plus 1, second term divided by first term, we get P plus 1. The series will converge if minus 1 less than or less than 1. So we use the common ratio into that inequality. Minus 1 less than P plus 1 less than 1. Solving for P, the inequality. Okay, we subtract 1 from all the terms. We get minus 2 less than P less than 0. Question B. Calculate the sum to infinity, S infinity. use the formula A over 1 minus R. Substituting into the formula, we get P divided by 1 minus of P plus 1. Common ratio is P plus 1. Simplifying, we get P over minus P, which is equal to minus 1. So the S infinity is equal to minus 1. Given the geometric series 2 times 3x minus 1 plus 2 times 3x minus 1 whole square plus 2 times 3x minus 1 whole cube plus etc. For which values of x will the series converge? By now, I'm sure that you know the method. We calculate the common ratio. That is our first step. Here we get the common ratio is 3x minus 1. We substitute into the inequality. That is our next step. So minus 1 less than 3x minus 1 less than 1. We solve for 1x. Okay. Adding 1 on all the three terms in the inequality, we get 0. Less than 3x less than 2. Now it is 3x. We want 1x. Divide all the three terms in the inequality by 3. So we get 0 less than 1x less than 2 over 3. The values of x lie between 0 and 2 over 3. Given that P equal to sigma k equal to 1 to infinity of kx minus 1 to the power, okay, a question in sigma notation. Question A, determine the values of x for which P converges. What is the difference here? Only thing, instead of giving the expanded form, it is given in the sigma notation. So we have to expand and find the series. So we start putting values for k from 1 to infinity. Okay, x minus 1 to the power 1, x minus 1 to the power 2, etc. And then we go for the common ratio. Common ratio is x minus 1, and we use the property minus 1 less than or less than 1. Substitute into that. We solve for x. We get 0 less than x less than 2. Question B, calculate the value of P, the sum to infinity, when x equal to 2 over 3. Okay. Look at the sigma notation. It is k equal to 1 to infinity. That is the sum of infinite converging series. And x is given. X is 2 over 3. We substitute into the formula for S infinity. A over 1 minus R. We substitute. X is 2 over 3. Okay. Then you can use the calculator at that stage and get the final answer, which is equal to minus 1. Another beautiful question. The first two terms of a convergent geometric series are k and 6. The first two terms, where k not equal to 0. The sum of the infinite series is 25. Calculate the value or values of k. Okay. So since we have the first two terms, okay, we can calculate the common ratio. R is equal to 6 over k. Therefore, S infinity is also available, equal to 25. Substituting A and R very carefully, we get k over 1 minus 6 over k equal to 25. Okay, we are simplifying k equal to 25 times 1 minus 6 over k. The bracket can be simplified. We get k minus 6 over k. Okay, multiply both sides by k. We get k square and minus 25k plus 150 equal to 0, the standard form of the quadratic equation in K, factorize K minus 10 times K minus 15. Therefore, K equal to 10 or K equal to 15. The possible values of K. That is the end of part 7. We have done a lot of questions on sequences and series through these videos. Subscribe and share these videos to your friends. Also, you try to get more questions from the internet, from the metric past papers. Practice them, practice yourself, and then you check the answers. Be confident on the topic. Okay, good luck.